Okay, so learning goal today, the student will understand how to solve equations using the distributive property. So we're adding it all together. Okay, first thing I want you guys to do, and I've got yours should be all up top. Okay, I want you to look at these and decide which ones have one operation and which ones have two operations and which ones have more than two operations. Okay, so when I say operations, that one we looked at the second on the warm-up, 5x plus 9 is 24. That would have two operations because I subtracted 9 and then I divided by 5. Okay, so look up there. Which one of those would only have one operation, one step for us to do? Sam?
72 equals n plus 12.
Yo, what would be my only operation there?
72 minus 12.
Yes, I would subtract 12 from both sides. It would only have one operation. Very good. Okay, and these don't go on top of, unfortunately, so we'll have to kind of put it around or draw a line. Yeah, if you want to fix it on yours, that's fine. You totally can. Okay, give me another one that needs one operation. Ashton.
A over 2.
Very good. What would you do there?
Multiply 2 by 2.
Yeah, you'd multiply both sides by 2. Very good. That would have one operation. Okay, all right. Which ones would need exactly two operations? James.
7.
Actually, that one's going to have more than two operations.
You have to figure out inside the parentheses.
Because you're going to have to distribute.
Yeah.
Then you're going to have to start. Okay. Another one? Taylor.
3a minus 7.
Yes, because on this one you would add a half to both sides, and then you would divide by 3. So that would be exactly two operations. Very good. Another one, Eva.
6s plus 13.9.
Very good. That would have exactly two operations. Whoops. Oh, mine went all crazy. All right. Yeah. Goofy. All right. Who cares? We know where it goes. All right. And then that leaves us with these last two. That these are going to take more because we're going to have to distribute. Then we're going to have to worry about solving them. Dan.
Is it always going to be anything in parentheses more than 3 2 operations?
More than likely. I mean, I could probably come up with something that wasn't, but most of them, yeah. All right, so let's look at this next slide. And we're going to distribute and solve. So it says solve the equation. So I'm going to start off, I'm going to draw my line so I have my two sides of my equation. I'm going to take negative 8 times x. Negative 8 times x would be negative 8x. I'm going to keep my plus sign. And negative 8 times 0.3. So 8 times 3 is 24. I'm going to move my decimal point. So negative 2.4.
Where'd you get that? You have to do
Negative 8 times 0.3.
Oh.
All right, equals 3.6. What would be my next step after that?
You have to get the x side.
Okay, and how do I do that?
I mean,
add
2.4.
I would have to add it. Why would I add it and not subtract it? Because it's a negative number. Because I want this right here to become 0, and the only way I can do that is to make it its opposite. So that's why it's actually adding the 2.4. So plus 2.4 on this side. So I get negative 8x equals 6. And then I'm going to use that fraction bar because I'm going to leave everything in fraction form. Okay, so I divide both sides by negative 8. Good. This side by negative 8. And then I reduce my fraction. So what goes into both 6 and 8? 2. So my final answer is negative 3/4. Negative 3/4. I'm just reducing my fraction. That's why I'm using that fraction bar.
Why'd you put the negative sign on the top this time?
Because the negative can go on the top or the bottom or out front. You just can't have two of them.
What if you have to?
What happens if you have two of them?
Positive. Because negative over negative equals positive.
Very good. You get a positive.
Then it really wouldn't make sense.
It wouldn't make sense. That would change your answer. Yeah. Sophia?
There'd be a negative sign on the right side of the fraction?
No, it always has to be on the left. Okay. All right, so next one. So now we're going to distribute a fraction. There are other ways to do this one. I'm going to stick with distributive property because if I show you too many tricks too quick, I think I'm gonna confuse you. So I'm gonna save some more tricks for later. But for right now, let's just do it with distributive property. So I'm gonna take 3/4 times 8. Some of you can do that mentally. If you can't, what I'm doing is I'm mentally right now going 3/4 times 8 over 1. So in my brain, I did 3 times 8 is 24, divided by 4 is 6. So that's what I'm doing in my head, but if you need to see it. Okay, minus, now I'm going to do 3/4 times 4. So in my brain, 3/4 times 4 over 1. In my brain, I'm cross-canceling the 4s, and I'm left with the 3. Okay. Now, this is why distributive property a lot of times is not a big deal, because all the fractions disappeared anyway. So you see, it's not a big deal to distribute. I can reduce what?
The 6b and the 3c.
No, I can't do anything with it yet. I gotta get rid of the b. So
Now you would add 3.
add 3. So then my
That would be
6b
1.
drops down. That would be 1.
B equals 1/6.
And then I would divide both sides by 6 using my fraction bar. So that b equals 1/6. And if you look at these are problems that would have been extremely hard for you to do mentally. There are several of you in here who are like, yep, I know the answer before we even started. I would not think that these would have been ones you could have done mentally very easily, if that makes sense. So you have to have a process. All right, let's look at these word problems because they're a little tricky. So let's see if we can set up a word problem using distributive property.
I could not figure those out at all.
I could.
Bunch of whiners.
I couldn't figure out everything. I just figured out 4, 5, 6.
4, 5, 6, or 7, huh?
Yeah, I have to.
All right. A family of 6 buys airline tickets online. Travel insurance costs $19 per ticket. The family is charged a total of $1,116. How much does the airline ticket cost? Each airline ticket is the same price. So you want to be able to write an equation. You guys think you already know the equation?
Yeah,
1,100.
Holy cow. Okay. All right. Ashton.
Is it 19x equals 1,116?
No?
It's 1,116 divided by.
No? Yes?
1,116 divided by
No.
19 equals x.
Sophia?
And it's 6 times 6x plus 19 equals 1.
You're the closest so far.
Where's the 6?
Taylor?
Oh, okay.
6.
19x plus 6. 6. 19x plus 6 equals 1,116.
No?
I got this one now.
I agree with this. A lot of you guys have said that. Okay. All right, Malia?
Is it 6 plus 19x equals
No?
1,000?
Gray?
Is it 19 times 6 equals?
No? Anna?
6x plus 19.
No?
Oh.
Okay. All right. Hold on. I love that you guys are really trying. So hold on. Let me help you a little bit. Okay. So you guys all understand that you're going to have a ticket price. And for each ticket, they're going to add what to it? What are they going to add to it? The $19, right? So we don't know the ticket price, so that's our X. So there-
x plus 19.
So there's...
6x plus
No.
19.
Hold on. Hold on. Hold on. Shh. Okay. Hold on. All right. So we're going to start with this. This is going to tell me the price of one ticket, right? One ticket, whatever that is. But I have 6 total. So parentheses times 6, because I'm going to buy 6 of them. If you just do 6x, then you just said that the 19 only got added one time. And the 19 has to be added to every ticket. Does that make sense? That's why you have to do this, get this, and then multiply it by 6. James.
Couldn't you do 6 times 19x?
Well, no, because the x has to go with the 6. See, this would be 6x, meaning I have to take 6 tickets plus 6 times 19, which is how much? 19 times 6, 54, 11, 114. So think about what I just did and see if that makes sense. 6 times the ticket price plus here's all my insurance. That has to equal that amount. Does that make sense? That's why distributive property works. Okay? I'm not going to finish solving it because I'm hoping by this point that you realize all you have to do is subtract 114 and divide by 6. I'm hoping that part's getting easier. Okay, let's try another word problem one that I think might trick ya. All right, I think this one's harder.
Oh gosh.
The last one I feel like you kind of makes sense after I explain it. Okay, you're going to mail 20 identical invitations weighing more than 1 ounce each. Okay, so you have a pretty heavy invitation. You get 20 of them. it's going to cost you 44 cents for the first ounce and plus 17 cents for each additional ounce. The postage for all the invitations costs $15.60. Write and solve an equation to find the weight of each invitation. All right, Jacob.
19 times 17 cents.
No.
Has anybody got
I know where I
math
got
class?
19, but that's not going to work. All right, Gavin.
Is it 19?
No.
Wait, 20?
No. 20. Okay, you can try.
20 times 0.17 plus 0.44 equals 15.6. No, because we still need to add.
James.
20 times, and then in parentheses, 0.44 plus 7.17x equals 15.
Got it.
How? Where did you get 20?
You did well.
20, I did 20.
Did anybody get it last class?
No, well, they didn't want to get. They're like silent. I don't know if they were asleep or if they all took a bunch of Benadryl today, but they were just all like lethargic. I think like drool was running out of their mouths a little. Yeah. Okay, now let's explain this so everybody understands what we're doing. We have our total, $15.60. Okay, so they're going to charge us 44 cents for the first ounce. So every single one is at least 44 cents plus 17 cents, but we don't know how much each of these are, and we know we have 20 of them. Does that make sense? So it's tricky. I know it's tricky. You want to work this one?
Yes, please.
Yes, please. Okay, it's going to be helpful to have a calculator because we've got 20 times 44, 0.44. So 44 doubled. It's $8.80, isn't it?
Oh, okay.
8.80 plus, okay, 20 times 17, so double 17, which would be 34, and move the decimal point, so 340. Check my math. Make sure I'm not making a silly mistake. Pretty please. Am I good?
Yeah.
Okay. And then from here,
You subtract 8.8.
yep, because that would be $8.80 in just the first ounce, so I'm taking that off. 8.8. All right. Somebody help me with that, man.
Oh, wow. Oh, boy.
$15.60 minus $8.80.
6.8. $6.40.
80.
I'm hearing 80. Yeah, right?
Yeah, not 80.
And then the last step would be to divide by 3.4. Yeah.
2. The answer's 2.
Okay, what does that mean if the answer's 2?
$2. That's the cost for each envelope.
That's how 2 ounces.
An extra 2 ounces.
Yeah.
So that means each invitation really weighed how much?
3 ounces.
3 ounces. So you paid 44 cents, and then you had to pay the 17 cents for 2 more.
Dang, 1
Yep.
ounce each. That's not very
Yep. All right, let's look at these next ones and make sure we can solve these.
That's scary.
It's not scary. Not scary. Okay, this is exactly like yesterday.
No, it's not.
Yes, it is.
But there's an E there. It wasn't there last time.
I can use any variable I want.
Dude, that's like
Okay, so you do distributive property, right? So 2 times E and 2 times 4. So we're just going to distribute. Yes.
8.
Yeah, 2E minus 8. And hey, look at that. It's the exact same thing we did yesterday. Exactly. All right, so let's go ahead and go to the next slide. And there are 2 on this one. Now, last hour wanted to try the first one on their own.
Yeah.
They were adamant.
No.
But then some people were adamant that they didn't because there were some on the homework last night that were similar. So would you like me to go through this one?
Yeah.
Can we do the next
How
one on
about-
our own?
And then we'll try the next one on our own. That's a great compromise. Okay, so we're going to start off with our 3B. So 3B plus, we're going to distribute. 2 times B is 2B minus 2 times 4 is 8 equals 47. What do you have to do when you get to this point? This was on the homework last
Separate
night.
your variables.
Sophia.
Then you have to add your variables.
Sophia.
Add your variables.
Yes. Put these 2 together to make 5B minus 8 equals 47. And then you just solve it from there. That's the only step. And we've gone over combining like terms before. Your mistakes if you made a mistake.
We're good.
You're good?
I think
Okay.
We'll be.
All right, then you guys can go ahead and get started on your digits homework. If you need to come talk to me about something, that's good.